Hello, architects. Are you building out a brand new shiny serverless system? You've implemented all of these event-driven best practices, you're delivering value really quickly, you're super excited about the future, and then realize you need to integrate your system back with a legacy monolith that just can't scale. It can't meet the demand, but you need to communicate with it. So how do you manage that pattern? Well, I've been there, I've done that, and I've completely overloaded many a legacy system by trying to integrate them together directly. So what patterns do you have in your toolbox to help enable this kind of integration? And of course, one of the patterns you have is the storage first API pattern that we've covered in a previous video. But in this specific situation, you need to integrate an event-driven system, a system driven by events, to a system that simply can't support events. It needs HTTP requests, and it also can't scale very quickly. So what patterns do you have? Well, let's have a look at that right now. And here we have your same application you've been working with for this entire video series, and you'll notice now we've got this additional customer handlers section. So if you deploy this into your own AWS account, you'll end up with 3 separate stacks. We've now got a shared stack, which is the event bus, the central event bus, the orders stack, which is what you've been working with in the previous videos, and then we've got this new customer stack. And none of these 3 are related. In the real world, these will be completely separate teams deployed independently. These are all in one CDK project just to make things a little bit easier for you to deploy. And as we left things in the previous video, you have this order status event publisher, and this is publishing a order created event to event bus. And this is the event that you're interested in. You work in the customers team, and you want to pull this into your legacy system. But remember, your legacy system is HTTP, event bus is an event bus. Of course it is. Now, one of the really interesting destinations, the targets you have in EventBridge is HTTP. You can make HTTP requests with EventBridge, which seems like a really easy solution. However, you're still going to encounter that scaling problem. Remember, one of the constraints we have is scale. Integrating EventBridge directly with a HTTP request means that as an influx of events hit EventBridge, they're going to be directly passed on to your legacy system, which means it might not be able to handle that scale. So what other options do you have? Well, you can introduce a Lambda function. So you can set up a Lambda function so that when the event hits EventBridge, your rule sends it to a Lambda function, and Lambda calls that legacy system. Also seems like a good pattern. You might be thinking, well, Lambda's event-driven compute, so surely the intuitive thing to do is to link event bus to Lambda, and Lambda makes the HTTP request. And this is kind of what's happening here. We've got the message coming in to our Lambda function, and then we're just making a request to the legacy system. In this case, I'm actually making a GET request to Google just to kind of simulate the fact that we need to make a HTTP request. That's all. So ignore the fact that it's Google. In the real world, this will be your actual legacy system. And again, event bus to Lambda, event-driven compute, everything scales, happy days, but you're still going to encounter that same problem where a sudden influx of events, which means you've got a sudden influx of Lambda invoked, which means you've got a sudden direct call to your legacy system. And the reason I mentioned storage first APIs at the start is because this same pattern applies if you're integrating with events as well as integrating with HTTP. You want to store them first, process them later. And you can settle that up within the CDK. So if we look at the customers stack we have here, and the first thing we do is importing our event bus from our shared stack. And we're doing that using the import value function of the CDK. And this is where you can specify the output of another stack. So if you just quickly look at the shared stack, you see we're outputting the event bus ARN, and we're outputting that into an export of shared event bus ARN. So in our customer stack, you can now import that event bus using the shared event bus ARN. So we've got the event bus now, and you're creating a queue, an order created queue. Remember, storage first, and SQS is an excellent mechanism for anything that's storage first. You then create a rule, the event bus rule, and we're looking for an order created event coming from the orders system. That's the pattern we're looking for event bridge to match for us. And then we're going to send that off to an SQSQ target. Of course, as I mentioned, this could be a new Lambda function as a target. It could equally be a new HTTP but it could equally be as well a new API destination, which would allow you to send this as a HTTP request. But remember, we're integrating with a system outside of our control. We can't control the load that's coming from this upstream system. So in this case, you want to integrate with a queue. So we've created the queue, our rule is targeting our queue, and then we have the actual Lambda function definition where we create our new .NET function, we have the handler and the project directory, and then importantly, we add an event source to our Lambda function. And that event source is something we're all familiar with now, which is the SQS event source. One thing you haven't seen in previous videos is actually the properties you have on that event source. And what these properties allow us to do is control how Lambda pulls messages from the queue. So what you're saying here is that we want a batch size of 5. We only want to batch up 5 messages together at any one time, no more. And you only ever want 2 concurrent Lambda functions reading from your queue. So if you're not familiar with how SQS and Lambda works, as your queue starts to build up with more and more messages, the Lambda pollers will also scale up in a pretty similar fashion, which means as your queue grows, the number of Lambda functions reading from the queue grows, allows you to meet the demands of your queue. However, you might want to control that, and that's what you're doing here. We're saying, actually, we only ever want 2 Lambda pollers ever reading from the queue, no more. Which actually means with the combination of these 2 values, you'll only ever have 10 messages maximum in transit to the legacy system at any one time. And then the code for the actual processing of the message is doing these in a for each, it's doing them one by one, which means actually you'll only ever have 2 requests in flight to your backend system at any one time. So we've just taken what is a completely unknown amount of load coming to our system and drilled that down to actually 2 requests in flight at any one time. Now, of course, you might be able to deal with more than that. Maybe you said the max concurrency is 10, so you're happy with a little bit more scale than that. But what you're doing here, really importantly, is you're controlling the load against your system. And even if you're not integrating with a legacy system, even if it is another serverless system, these kind of patterns to protect your system against upstream systems is something I'd recommend doing in almost all cases, in almost all of the edges, the boundaries, the integration points of your system. Implement this same pattern. So let's go and see this in action now. So as we have for most of this series, we can make a request to our create order endpoint, and we'll just set the customer name back to something sensible, and we get our response back nice and quickly, as you are all familiar with. And let's go over to the Lambda console now and look at our event publisher. And let's just grab the logs for our event publisher, and you can make sure that, as expected, the event gets published. And here we are with the event, and if we look through this set of data, we can see there 528DA1E3, 528DA1E3. Excellent, so we've got that event's been published to EventBridge as we would expect. So let's now go back and actually have a look at our new customers stack customer already created handler. So here you have the handler for our customer system. This is the integration point for your legacy system, and you can have a look at the logs in here, and what you will see is that it's been triggered, which means our event bus rule is set up correctly, and you have 2 events coming in here. And if you just take a look at one of these, you will see that somewhere in here you will have the order ID, which is 528DA1E3, and then of course you've got the request, making request to the legacy system, and then the HTTP result is okay. Of course, we're running a GET request to Google. You'd be pretty shocked if that wasn't okay. There's probably bigger problems with your system if Google is not working. And you can see that it's very quick. You know, we had the 1108 or 2 is the point in which, 1108 28. This one here, this is the last request we made. That was the point at which it hit our legacy system. And if you look back at the original request for our for the order status, create order handler, there we go, that's the one we want. And if you have a look at the first moment that this actually hit our create order handler, the point in which it was presented to the database, that was 11:07. Where are we? 11:08:27. That's the most recent request that hit our system. So it actually took less than 2 seconds for it to go from the API, SQS, Lambda, DynamoDB, Lambda, Event Bridge, SQS, consuming Lambda function in the customer system, which sounds like a really long chain, but actually these things happen really quickly once everything's warmed up and everything's ready to go. So what you've seen there is a pattern you can use to integrate legacy systems with potentially more scalable serverless systems. And even if you're integrating two serverless systems together, introducing these buffers, these protections around the boundaries of your system really helps you keep control of how your system functions and stops being overloaded by systems outside of your control. As always, if you've liked this video, please like and please subscribe. If there's any other content you'd like to see me cover, please feel free to reach out on social media or in the comments below. And of course, I will see you all next week.